we're going to look at a few other small vector details, but rather significant in the story of the vector as we're building up various types of skills. So one of those types of problems is, what if we have a vector that goes from one particular point to another particular point? Could we write that vector? And it's almost always useful to give some sort of a sketch or a graph if you're visually inclined, but some people kind of like going from formulas. So if, for example, we were going from the origin in 2 dimensions, 0, 0, to the point 4, 7, well, that vector u would equal, or vector v, whatever you're going to call it, would be the vector that goes right 4 units and up 7 units. Or you could write it as 4i plus 7j if you're missing the physics notation, because I haven't used it in a while. If the vector is not starting at the origin, so let's say it goes from the point -3, 4 to the point 6, 2, so from one point to the next point, a visual may be useful. So you might look at it as, okay, so the vector is at -3, 4 when we start, but it ends at the point 6, 2, so it looks like that. And you can research in a book or go online for a formula if you have the x coordinates. It's going to remind you of some algebra formulas from your past. But you could also just count. I mean, from -3 to 6 is a distance or a change of +9. And from 4 to 2 would be a drop or a reduction of 2 units. So it's not really all that difficult to do that. And maybe you can just do it by observing the numbers in the 2 points. So that would be the vector that goes from this point to that point. If we reverse this order, then we would be reversing this to -9 and +2. Here's a couple more quick ones. If your first point from -8, 5 to the point 0, 5, I think you will find that in this case that you are beginning on the x-axis here, and 0, 5 is here. You're going to the right, you're not going up or down. So that would be the vector that increases in the x direction by 8, but the y direction doesn't change at all. And in the physics notation, you would say that is the vector 8i. And last little piece for this particular type of problem, if we started at the same -8, 5, but we went to the point -8, 0, that would be starting here and going down. And it turns out to be down exactly 5 units. So don't go left or right, go down 5 units, or -5j would be that vector. Again, building blocks to vectors, you may not need all of these little skills on a regular basis, but you need to be familiar with all of them in case it comes up in part of a formula development. Now, let me show you something else. This little example is also not particularly difficult, but something that's not shown anywhere else yet in my little video segments. The terminal point would be the ending point of a vector. And the ending point of a vector, well, I guess we need a couple of things. The vector itself, let's suppose it was negative 5i plus 3j. For those of you that like the little hats on it, there you go. And let's suppose our initial point, which is our starting point, is the point 3, comma 3. The question is, where does it end? Where does it end? There are formulas that you could look up for this. The purpose of this video isn't to reteach all of vectors, but to provide some little pieces as quick little mini instruction or mini reminders. What about the visual? If you start at the point 3, 3 and you go left 5 units, left 5 and up 3, left 5 and up 3, what is that new point that we just ended at? Well, I think you will find if you go left 5 units, that's 2 units to the left of the origin, negative 2. And if you start 3 units up and you add 3 more units, that is 6 units up. So negative 2, 6 would be your terminal point. All right, one more quick little mini vector item. Remember, you have a pause button. Use it if you need to. All right, here we go. Given a line or an equation of line, could we convert its slope into a vector? Could we take the slope 3 over 5, which my high school chemistry teacher would have said, yes, chemistry teacher, would have said, oh, that's a change of y over a change of x. Could I write this as a vector? And one way to do that for the vector would be to think of this as the x component would be that change in x and the y component would be that change in y, which would just simply be that our slope as a vector would be the vector 5, comma 3. Or I could, instead of going up 3 and over 5 and going that direction, I could reverse the minus signs and have it going left 5 and down 3. Or I could say, well, what if I went right 10 units and up 6 units? I got to calm down a little bit here. The directions say to write a possible vector for the slope. I suggest that I would have been done if this was my homework problem as soon as I wrote that vector. Change in x, change in y, written as a vector. Small little vector details applied to some previously used mathematics. Important stuff. Stick around, come back for some more.